Ferroelectric Random Access Memory from Cell Structure Application. The ferroelectric random access memory, known as FRAM or FRAM, is an ideal, non-volatile memory that provides the benefits of both dynamic RAM and ROM. This type of memory consumes less power, is many times faster and provides more than 1 trillion 1013 read-write cycles. The data stored in FRAM memories is not lost even when the power is removed. FRAM is unaffected by magnetic fields as there is no ferrous material, iron, in the chip. Ferroelectric Random Access Memory, FRAM, FRAM or FRAM, is a form of non-volatile memory similar to DRAM in architecture. However, it makes use of a ferroelectric layer in place of a dielectric layer in order to attain non-volatility. Considered as one potential alternative for non-volatile random access memory technologies, ferroelectric random access memory provides the same features as that of flash memory. The memory cell consists of a ferroelectric capacitor and a MOS transistor, and data is read by applying an electric field to the capacitor. If the external field is removed from FRAM, it will remain polarized. This is termed as remnant polarization, which is nonlinear polarization. Hence, ferroelectric random access memory is non-volatile. Ferroelectric crystal is made up of ionic crystals, and the structure is cubic with barium ions at the cube corners, oxygen ions at the face centers and titanium ion at the body center. Whenever an electric field is applied across the face of the crystal, the atom moves in the direction of the given field. While reversing the field causes the atom to move in the opposite direction. The atom positions at the top and bottom of the crystals are said to be stable. The central atom moves in the direction of the applied electric field. As the atom gets displaced through an energy barrier in the crystal, it causes a current pulse, and the internal circuit sends this spike and sets the memory. The central atom remains stationary if the electric field is removed from the crystal, thus preserving the state of the memory. Operation principle of ferroelectric random access memory includes two functions. Read operation. Write operation. Read operation in ferroelectric random access memory, FRAM. When the electric field is applied across the capacitor, the mobile atoms will get displaced across the crystals in the direction of the field, resulting in a current pulse. Sense amplifier detects the pulse representing stored data as either 0 or 1. As the read operation memory involves a change of state, the circuit will automatically restore the memory state, as each read access is accompanied by a precharge operation that restores the memory state. Although the read operation destroys the data stored in the capacitor, it is written back by the sense amplifier under 70 ns, similar to DRAM. Write operation in ferroelectric random access memory, FRAM. Similar to read operation, a precharge operation follows a write access. The circuit applies write data to the ferroelectric capacitors. If necessary, the new data simply switches the state of the ferroelectric crystals. Writing operation includes two steps. Writing 1 into the memory cell. Writing 0 into the memory cell. Writing 1 into the memory cell. Initially, bit line is applied with the source voltage as shown in the fig. 4. This allows full voltage across the ferroelectric capacitor. Plate enable is pulsed. Word line stays activated until the bit line is driven back to 0 and plate enable is pulled down completely. The final state of the capacitor is negative. Writing 0 into the memory cell. In this operation, bit line is driven to 0V before activating the word line. This is followed by word line staying activated and plate enable is pulled down completely, which is similar to writing 1. The data remains in the cell even when the transistor is in off state and hence it is non-volatile. The applications of ferroelectric random access memory are: it is used in industrial microcontrollers. They are also used in radio frequency identification. It is used in electronic metering, medical equipment. FRAM memories are also used in spacecrafts. Advantages of ferroelectric random access memory, FRAM. The advantages of ferroelectric random access memory are: data retention as the memory is non-volatile. Low power consumption. Operates at low voltage. Disadvantages of ferroelectric random access memory, FRAM. The disadvantages of ferroelectric random access memory, FRAM, are: cost is high. Density is less compared to DRAM and SRAM.